Well, good evening, everybody. Tonight's video is going to be on Lesson 4.1, and as you can see, Lesson 4.1 is on divisibility and factors, and I have a whole motley crew of people that stopped by to help with the video. In fact, let's see, here's a picture of most of us. And so there you go. So say hi, introduce yourselves.
I'm Walker.
He's not pictured because he didn't get here in time.
Yeah. Hi, I'm Jake. My name is Henry.
Wait, hold on. Let's fix Jake. There we go. Here's Jake.
And I've been.
All right, Henry. Oh, yeah, Henry doesn't need much help. We'll just give Henry some horns here. All right. And maybe some whiskers. Okay, who else do we have here?
Austin.
Austin got in a fight after school, so he came to help.
Yeah.
Who else do we got?
Ryan.
Devan is actually from Course 1, but he's helping with the Pre-Algebra videos. You can't really see him, but he's up here. And actually, Devan has already done the divisibility lesson, and so he's got a leg up. So he's going to be our expert for today.
I'm your expert.
We've got Kevin hiding back here, but I think Kevin bugged out, didn't he?
Yeah.
Yep, Kevin's not here.
So did Jake.
And then you got Mr. Gunn, and Mr. Gunn is weird. And let's see, who am I missing?
Ryan.
Oh, look, there's Ryan. Well, I was kidding you. There's only 3/4 of a Ryan. So there we go. All right, so without further ado, let's get to the matter at hand. All right, so we're talking about divisibility and factors. And so let's go ahead and let's break down the basic divisibility rules. Now, the reality is we're going to do some really cool ones, but all you really need to know are the first 5 of these. Okay, so remember that. The first 5 are the divisibility rules that you're going to actually be responsible for on a quiz or test. And I think Devant's making that noise because he remembers one of the questions that was on his daily quiz from this well, it wasn't the same video, but it was the same content material. All right, so let's start with the first 3 numbers that we're going to go over the divisibility rules. Okay, what do you guys think? For 2, 5, and 10, why are these the easy ones?
Because
Somebody, one person.
Okay, Henry. I don't know.
Okay, Henry.
All right.
Henry, why?
Okay, if it's even, then it's divisible by 2.
Okay, stop. Back up. What do 2, 5, and 10 all have in common?
To
tell whether something's divisible by 10,
look at the end
you
of the
just look at the
number.
last digit.
Yeah.
All right, now, what do you look for? So, Henry, when is something divisible by 2? If the last digit is what?
If the last digit is even.
Okay, so the last digit is a 0, 2, 4, 6, or 8. So if the last digit is even, then the whole number is divisible by 2. Let's skip down to number 10. Ryan, when is a number going to be divisible by 10? If the last digit...
0.
Yeah, the last digit has to be 0. Okay? And finally, when is a number divisible by 5, Jake?
If it ends in a 5 or a 0.
Yeah, that's another way to say it. So let's phrase it that way. If it ends in either a 5 or a 0. Now, the interesting thing about this is if a number like 60, where it ends in a 0, okay, well, actually, wait a second. Isn't that all 3?
Yeah.
Right, because it ends in a 0, so it's divisible by 10. It ends in a 5 or 0, so it's divisible by 5. And it's even, because 0 is even. So actually, anything that ends in a 0 is automatically divisible by 2, 5, and 10. And the further similarity is that, again, all of these, all you do is look at the last digit. So you could have some crazy number, like 52,000. Sorry, we had a little pop-up, and it paused the video. So once again, to reiterate, 2, 5, and 10 are all in blue because what they have in common is all we do is look at the last digit. So some really crazy number like 52,362, it ends in a 2. Therefore, it's divisible by 2. All right, the next 2 rules are 3 and 9. And 3 and 9, again, are going to be grouped together, so we'll make these both red because in both of these, in fact, let's go ahead and start it out. What do I do first to test for divisibility by 3 or 9?
All you do is you add up all the digits.
Right. For both of these, we're going to start by adding the digits in the number. Okay? And that means, so if I have a number like 125, what I mean is add 1 plus 2 plus 5. So what would the sum of the digits here be?
8.
Okay, good. Now, then for the 3 rule, you just test. You test the sum in both of these, and if 3 divides the sum,
Which it does not.
then the number is divisible by 3, and if 9 divides the sum, then all right. So in this case, it doesn't. But what if it was 1,250? Let's add a 1 to the end of this. Okay, now what does it add up to?
6.
Try again.
9.
Wow.
9.
That's what we call group mentality. Somebody just yells out 6 and everybody yells out 6. Okay, so let's try again. 1 plus 2 equals 3. 3 plus 5 equals 8. And 8 plus 1 equals 6. Wow, I'm so proud of these guys. All right, now, focus. Now, because 1,251, because its digits add up to 9, what does that mean about divisibility? It means it's divisible by both 3 and 9.
Yeah, because 3 goes into 9.
Right, right. Now, here's another thing. So what we've learned up here is that if a number ends in 0, that it actually works for 2, 5, and 10. Well, similarly, if we add up the digits and it comes out to be like 9 or 18 or 27, then 9 divides it. But think about it. If 9 divides 9, 18, and 27, wouldn't 3 automatically? 3, because 3 goes into 9. Exactly, Henry Beck. Good job. All right, so those are the basic divisibility rules, and those are the ones you're really responsible for. Okay, now, let's go on. There are some kind of crazy rules. All right, now these are not the crazy ones. These are just some extra ones. Now, these are not going to be necessarily responsible in your book, but they are good ones to know. Okay, so for the extra rules, we're talking about numbers like 4, 8, 7. You saw those other ones flash up. We'll come back to those in a second. All right, so the 4 and the 8 rule, they're kind of like the 2 rule. What you do with 4, first of all, don't even bother with 4 or 8 or actually even 6. Okay, don't bother with any of these unless the number's at least even, right? Yeah. If the number's not even, 4, 6, and 8 are not going to go into them. Yeah. All right, so if the number's even, here's what I do for 4. Take half the number, so actually just divide it in half. Okay, and if it's still an even number, it means you could have taken another 2 out, right? Yeah. Well, that means if you can take 1 2 out, which is what you did when you take half, and then you can take another 2 out because it's still even, you could have taken 2. So that's one way to test for 4. Another way to test for 4, let's say at a really big number, like 56,724. It turns out, if you just look at the last 2 digits, if the last 2 digits are divisible by 4, and obviously 24 is 4 times 6, then the whole number is. You don't have to test the whole thing. So both of those are 4 rules. Similarly, I don't know if I can say that number. That same thing with 8, except this time you have to take half twice. Okay, so take a number like 1,000. What's half of 1,000? 500. All right, that's 1. We took half 1. So it's still even. So 500. So all right, hold on. Think. So if we take half of 1,000, we get 500. It's still even. So that means it was divisible by 4. Now take half of 500. It gets 250. It's still even. So that means it's divisible by 8. So take half twice, and if it's still even, then it was divisible by 8. If you take half the number once, that was the 4 rule. If it's, again, it's the same rule. If it's still even, then it's divisible by 4. Now, there's another similar rule for a really, really long number. Again, let's take 56,724. Another way to test the 8 rule is you can just test the last 3 digits. Not 2 this time, but 3. So if 724 is divisible by 8, then so is the whole number. And this one, the answer is no. And sometimes it's easier just to do the division to see if it goes in. 8 goes into 72 exactly 9 times, right? Yeah. But then you get a remainder of 4. So it goes in 9D and a half times. So it's 90.5, and that is not even. So that's really what we're getting at. We get these fancy divisibility rules, but sometimes it's easier just to do the division and see if it works. Okay? If you had a calculator, for instance, if you just punch the number in, if it comes out an integer, it means they were divisible. Yeah. If it comes out something like 0.258, then they weren't. That's bad. Okay. Finally, for 6, and 6 is going to build us to a general rule. Here's the rule for 6. 6 is the same thing as 2 times 3, right?
Yeah.
We already said you wouldn't even bother trying to test for whether or not something's divisible by 6 unless it was even. Well, in other words, we already checked the 2 rule, didn't we?
Yeah.
All right, so now check the 3 rule. Add up the digits. If it's divisible by 3, then what have we just shown about the number? It's divisible by both 2 and 3. Well, how do you get 6? 6 is 2 times 3. So the divisibility for rule for something that's a product of 2 other simple numbers that have rules is just do both rules. So for instance, suppose we knew.
You're hitting on me.
Oh,
sorry.
Everyone, I gotta go.
Okay, well, Austin just got stolen away from us, so we'll finish the video without him. Take care, Austin.
Yeah.
All right. So in general, if you have a number that's a product like 14, if you know whether or not it's divisible by 2 and 7, if the answer is yes to both of those, then the answer is also divisible by 14. If the answer is no to either of those, then the number is not divisible by 14. Which brings us to the crazy rules. There are actually divisibility rules. We call them the weird rules for 7, 11, and 13. Now, 7 is my favorite one. It's one I actually use in normal life.
Oh, really?
All right, so the rule for 7, okay, a number is divisible by 7 if you can take the last digit and literally rip it off. So take the number I'm just going to do an example here. So take the number 455. You literally take the last digit and you rip it off, which would leave you with what? 45?
5.
Now, take the 5 and double it. Always you always multiply by 2, so you get 10, and you subtract that off of the numbers that were left. So the 45, and you get 35. Now, if this number right here is divisible by 7, so was the original number. So since this one worked,
Yes.
455 is divisible by 7. Let's try another one.
Cool.
Let's try 287. So again, rip off the last digit and double it. What would 7 double be? 14. Here's another way to show the work. We'll put the 14 right there. 28 minus 14 is 14. 7 goes into 14.
Oh my God.
So both of these numbers, both 455 and 287 were divisible by 7.
Are you doing
Okay.
for the Wildcats?
Now, the next one is the divisibility by 11 rule. So let's take the same number, 455, and see if 11 goes into it. All right, so what we do for that is now we take the last, I'm sorry, I'm in the 11 rule. So what we do for this is we take all the odd digits. So in this case, the odd digits, all right, so here's the deal. You take the odd digits, which in this case are the 4 and 5, and you add them together. So that gives me 9. We'll do that in yellow. Then you take the other digits, which in this case is just 5, okay? And what we do now, I don't think this one's going to work. Oh, yeah. Okay. So we subtract them. We take the difference. And so 9 minus 5 is 4. Now, this number, if this difference is divisible by 11, so is the original number. If it's not, then neither was the original number. So it turns out 455 is not divisible by 11. So let's try this rule with another number that might actually be divisible. Okay? So let's take a really crazy huge number. All right. We're running out of room here, but I'll do it in green. So let's take the number 28,358. This has a lot more digits, so let's look at what we're doing. So take the odd digits, that's the 5th, the 3rd, and the 1st, and let's add those all up. So 2 plus 3 plus 8 adds up to 13, agreed?
Mm-hmm.
All right, now let's add up the even digits. 8 plus 5 is?
11.
Try again. 8 plus 5. I know it looks like a 3.
Looks like a 3.
All right,
Okay.
it was supposed to be a 5. So 8 plus 5 is? 13. And if you take the difference, you get 0. Now, be careful. Does 11 go evenly into 0?
Yes.
11 times 0
Yeah, it's
equals
0.
0. So it works. So this number, 28,358, is divisible by 11. So that's the 11 rule. Told you these are crazy rules. All right, the last rule that I kind of like is the 13 rule. So again, let's take 455, rip off the last digit like we did with the 7 rule, except this time you multiply by 4. And instead of subtracting, this time we add. So 5 times 4 is 20. Let's go ahead and put this over here next to the 45. Add them together and you get 65. Now, does 13 go into 65? Think about it. 13 times 5 equals 65. So if 13 goes into this number, it means the original number, 455, was also divisible by 13.
But you can also
But hold on, here's something really cool. What if you didn't know that? We'll take the number 65, okay, rip off the last digit. We're doing the divisibility by 13 rule again. Multiply by 4, you get what?
20.
20 plus 6 is?
26.
26. And now 26 is easily divisible by 13. So because this is divisible,
goes
because
into
13 times
twice.
2, so that means that 65 was divisible by 13, and that means that 455 was divisible by 13.
Oh, cool.
I'm going to cheat with a calculator. It turns out 455 divided by 13 comes out to be exactly 35. So, yup, our rule worked. So that's the 7, the 11, and the 13 rule. Now, if you forget these 3 rules, what could you always do?
Look it up.
Well, not look
Like
it up.
we did with
Just do the
number
division, right? Just do the division. So take 455. Well, yeah, okay, you can look up the rules.
Like we
But
did.
let's just divide it. 455 divided by 11. 11 goes into 45 4 times, and you get 44. You get a remainder of 15. And does 11 go evenly into 15?
No.
No, it goes in once, but we're going to get a remainder of 4. So right there, it's not divisible. So you can always just divide these to test whether or not they're divisible. But for a lot of them, we have these kind of slick divisibility rules. For 4, 8, and 6, there's kind of cool rules. And especially if you go all the way back to 2, 5, 10, 3, and 9. These are the 5 that you're going to actually be tested on. All right, so here's the deal. Let's do a
Those are
little...
the easiest,
Yeah,
right?
they totally are. So let's do a little bit of practice here. Okay, so when I say test for divisibility, what I mean is test whether 2, 3, 5, 9, or 10 go into a number. Okay? And so you're just going to take a number. So like take 255 and test for divisibility by 2, 3, 5, 9, 10. So you look at the last digit. Do 2, 5, or 10 go in?
No.
That's what... Come on, really, guys?
Yes.
Yes.
5 does because it ends in a
Five.
5. Yeah, that was kind of sloppy, so I'm going to fix the 5 in the middle. All right, so we're going to write down the ones that divide it. So 5 divides it. All right, now add it up. What is 2 plus 5 plus 5?
2 plus 5 plus 5
12.
equals 12.
So that means 3 goes into it, but does 9? No, so there's my answer. Which numbers? So all you do is write down the numbers that actually work. So 3 and 5 both work for this. How about 460? What goes into 460?
2, 5, 10.
2, 5,
Okay, 2, 5, 10 without even really thinking about it because it ended with a what?
0.
Right. Add 4 plus 6 plus 0. What do you get?
10.
10. That's not divisible by 3, and it's not divisible by 9, so that's it for this one.
Yeah.
All right? Let's do one more.
Are you guys...
Let's do 1,260.
Oh, yeah.
We're not going to do the extra
Yeah.
row, so we're
Okay.
only testing for these numbers right here. 2, 3, 5, 9, 10.
Okay.
Okay, 1,260. It ends in a
0.
0.
0, so you don't even have to
5,
think about
10.
2, 5, and 10.
Yep.
All right? Now add up the digits. What's it add up to?
9.
9. So it's
So
divisible by
3
the
and-
3 and
and
9.
3.
So this one is actually divisible by all
All
of
of
them.
them.
Okay, one last one. Okay? How about 59? Okay, what does it end with? 9. So 2, 5, 10?
No.
No.
No, none of those. What does it add up to?
Oh, it adds up to
14.
14.
14. So neither
none
9 and
of
3.
them. None
So,
of
so what you write here, this is not a trick question. The answer is none, and that's okay. So we tested it by the divisibility by our 5 our 5 principal factors. Why are they not prime factors, by the way?
Because. What?
2, 3, and 5 are prime, right?
Yeah.
What about 9 and 10?
Nope.
Not
2,
prime.
3,
So,
they-
so I shouldn't say these are our prime factors. These are our principal factors. These are the main numbers that we care about for divisibility.
And
Right?
2, 3,
11,
5,
13.
7, and 11.
Yeah, and then we got the
Not
crate.
one. Not one.
Okay, focus. Jake, I'm not going to have you on any more videos. So, you also have the rules for 4 and 8. You can remember those. 6 is kind of a handy one, and that works for all their products. And then we did the crazy ones, which were 7, 11, and 13. Okay, guys, we're up to almost 17 minutes, so let's go ahead and sign off. In class tomorrow, you'll go ahead and you'll practice these. But again, thank you very much for watching our video, and logging off all of my crazy friends here. Say goodbye, guys.
Bye!